Good day, students. How are you doing? Hope you are good. We are moving on to the next concept of our mathematics, and our topic for today is radian measure. Why do we measure in radian? As long as you have a concept that deals with circle and you are calculating angles or sine, it is very, very important that you measure in radian and you calculate also in radian. The reason why we calculate mostly in radian is to avoid large numbers of values. With radian, this angle can be measured, most especially when we are talking about geographical measurement, navigation, space measurement. So we avoid the use of degrees in order to get our angle accurately. So that is why we measure in radian. So basically, our objective for today is, at the end of the lesson, you as an individual student will be able to convert angles between degrees and in radian. In subsequent lessons, you can use this angle in radian to calculate any required concept like the length of arc, area of sector, perimeter of segment, or area of segment. For today, our major concern and focus will be on how to convert angles between radian and degrees. Now, if you want to measure in radian, the basic concept is the circle and the angle at the center. We know that the angle at the center is 360. The sum of angle at the center is 360. Then any distance from the center to any point on the circumference of circle is a radius. Suppose we have any two given radius, and let's say this is the first radius and the second radius. An angle is formed here. So that angle we want to measure it in radian. So what do? You can only measure in radian when the radius given is the same thing as the length of arc. Just as we know, the length of arc is just a fractional part of the circumference along the circle. So the concept of radians comes in when the radius of the circle is the same thing as the length of arc, just like as you have it in the diagram. So you apply that concept in such a way that the length of arc is the same thing as the radius of circle. If you have that, you have 1 radian. So the concept for 1 radian is the length of the arc must be the same thing as the radius of the circle, which is very, very important, please. So now, here we have the concept. The first concept is, we know that this angle here is a fractional part of the angle at the center, meaning that 1 radian is a fractional part of 360. So in proportionality, since we are considering the length of arc to be the same thing as the radius, then we say that the arc, which is r, is a fractional part of the whole of the circumference. And the circumference of circle is 2 pi r. When you talk about the circle, we are not talking about the area. We are talking about the distance run along the circle, which gives us the circumference. So carrying out our simple mathematical exploration, you now discover that for us to simplify this, I can multiply both sides by 360. So if I multiply both sides by 360, I simplify. This cancel this, and I'm left with this. Please. So if I cross multiply, you can see that 2 pi radian equals to 360 r. Then I divide both sides by r, then 2 pi equals 360 degrees. So it simply says that 2 pi radian equals to 360. If 2 pi radian is 360, so what will be the value of pi? I divide both sides by 2. So when you divide both sides by 2, it simply means pi equals to 180 degrees. So everything is explicit here, that when you look at this, 1 pi equals to 180, 1 radian equals 180 degrees over pi, simply implies that pi radian equals 180 degrees. And also 2 pi radian equals 360 degrees. That is just the concept. But basically, this concept, you don't need to derive it. The most important thing is note that 2 pi in radian equals 360 degrees. That is the first important thing which you must take note of. And the second one is pi in radian is 180 degrees. This is the basic concept, the basic idea that you need to convert. So if you get this idea, the whole thing is okay. Let's move to the next concept. Now, we want to convert between degrees and radians. Simply means if an angle is given in degrees, how do you convert it to radian? Now, from our previous idea, is when you are converting from degrees to radian, you multiply your angle in degrees by pi over 180. You have it there. When you convert from degrees to radian, please, you multiply the degrees, that is any angle that is given, you multiply it by pi over 180 degrees. And let's look at the first example. You were given 30 degrees and you have to convert 30 degrees to radians. This is very simple. Just like I trust you and I know you can do it. This is just an illustration. Now, I'm converting 30 degrees into radian. So all I need to do, since I know that any angle must be multiplied by pi over 180, I will take my 30 degrees and multiply it by pi over 180 degrees. And I believe for you it's a simple calculation. You divide both sides. You cancel this 1 and here is 6. So your answer is pi over 6 in radian. So this is very simple. If you are given any angle, you can do it. Follow the same thing in example 2. You get your answer to be pi multiplied by 4 over 9 in radian, which gives you 4 pi over 9 radian. Please, when you are calculating this and you use your calculator, remember to change the mode of your calculator from degree to radian. This you can do by pressing your shift, go to the mode. When you get the mode, you will see where radian RAD is written. You press the figure and you get it in radian and you can calculate. Sometimes, if you leave your answer as 4 pi over 9 radian is correct, and if you take it to decimal using your calculator, it's the same thing. It doesn't make any difference. So in summary, when you are converting from degrees to radian, you only multiply the degrees by pi over 180. Before we convert from radian to degrees, I believe by now you can practice, take any angle. Take, for instance, you can take angle of 90 degrees. What will be the answer? Definitely, I expect you to get pi over 2 radian if you practice the question. So we move to the next one. Converting from radians to degree. It's the same thing. If that angle is given in radian and you are converting to degrees, all you need to do is you multiply by the multiplicative inverse of the previous one. And the multiplicative inverse of pi over 180 is 180 over pi. You flip. The first one, when you convert from degree to radian, you use pi over 180. So when you are converting from radians to degrees, you just flip, is 180 over pi. Now, the first example, you were given pi over 6 to convert to degrees. Don't forget, the pi over 6 is in radian, and you are converting it to degrees. And one of the ways you can know that is that whenever you are talking about radians angle in measurement, you are talking about pi. And when it comes to degrees will not take pi, only radians angle take pi. So this pi over 6 is in radian, so I'm converting this to degrees. So all I need to do is multiply it by 180 over pi. So this is pi over 6 times 180 over pi. With our simple calculation, you divide this and divide 180 by 6, you will get 30 degrees. You can see the relationship between the two. So then moving to the second example, you do the same thing as the first example, you will get the same value. And your answer must always be in degrees, please. When you calculate your value like the first one and you leave it as 30, I won't assume that you are accurate. It can be 30 kilometers, it can be 30 centimeters, 30 what? The unit of your answer is very, very important. Here, you make sure you use 30 degrees, and here is 315 degrees. Now, this is just the summary of the diagram. When you take any angle, it's going to help you in your calculation. Any angle that falls within this range, you can easily check. You discover that it's very, very accurate. Quick summary. We calculated that 360 degrees is 2 pi and 180 degree is pi. So if you look at 90, it should be pi over 2, and you look at 270, this is 3 over 2 pi. These are the 4 cardinal determinants of your angle from degrees to radians. So with this, I believe I give you the basic idea, the concept that you need to know how to convert from 1 degree in radians and from radians to degree. So with this, I believe this summary note will help you to solve many questions and even questions beyond conversion from radians to degree or degrees to radian. In the subsequent class, we are going to make use of this concept basically in radian to calculate length of arc, sector area, and the concept under the segment. So for this, while you stay relaxing, you can practice this. I will upload some worksheet for you, and when you try the worksheet, and I believe you go to your course materials, go to page 1511, exercise 12A, and solve the question. Have a nice day and enjoy your stay. Thank you.